there's this function and it's called the unit step function. And the unit step is basically something that we call u of t. And it basically is 1 for t greater than or equal to 0. And we'll just say like this. And you say, well, what is it for equal to 0? And it's like kind of ish, not entirely defined. So just don't question it because that's not the job of learning. So anyway, unit step basically looks like this. It's 0 and then it's 1. And you're like, wow, why do I care? Okay, I care because of this. So set up a function that's like, I don't know, f of t is equal to t plus 1. So basically it looks like this, right? Right? No, wait, not like that. It looks like this. It intersects at 1 and then it's like a 1-to-1 thingy, right? Because the slope is 1 and it intersects at 1. All right, so basically the idea is if I have a function like that, but I only care about it for t greater than 0, that what I can do is I can take my regular function and I can multiply it by a unit step function, okay? So essentially what I'm going to do is I'm going to take this guy and I'm going to multiply it times this one. Now, why do I care? Well, I'll show you. So if I multiply the first guy times the second guy, what I end up with is kind of an interesting little phenomenon. All right, so basically from 0 or negative infinity to 0, I'm multiplying 0 times 0. So I have, like in the blue section here, I have, like in the first part, I have blah, okay? But in the second part, I have 0. And everybody knows that blah times 0 equals 0. So essentially what happens is it zeroes out the first part of the function. Now, in the second part of the function, I have something called t plus 1. And so I have t plus 1, and that's in the yellow section. And then whenever I multiply it by the corresponding section of the unit step function, that is just 1. And everybody knows that t plus 1 times 1 is t plus 1, right? Because that's the only thing that it could be. So essentially what I have is I have 0, and then I have t plus 1, like that, except that doesn't look like a slope of 1. That looks like a slope of 1. So what I've essentially done is I've multiplied a function by the piecewise function or by the unit step function, and I've essentially ended up with a piecewise function. And this piecewise function, so this right here, one way that I could write it is u of t times t plus 1. So that's one way to say it, or I can write it by saying that f of t is equal to t plus 1 for t greater than 0, and it's equal to 0 otherwise. Something along those lines. So basically the unit step function allows us to write a piecewise function without making it piecewisey, which is kind of neat. Now, you can do this, let's say that instead of having the cutoff at t being equal to 0, I had the cutoff somewhere else. So let's say that I had, right, so I'm going to draw in my functions and I'm going to multiply it by something and I want to get something else, except this is too big. Let's try this again. So let's say that I have this t plus 1 function, and it looks like it always has, like this. Okay, and really what I want is I want to multiply it by something, but at the end of the day, essentially what I want is I don't want to turn it on until, say, 1, 2. Okay, so it's going to intersect here. So basically, I don't want to see the t plus 1 function show up until here. Okay, does that kind of make sense? So basically what I want is I want a function that is defined such that it's t plus 1 for all values of t greater than 2 or equal to 2. Again, don't freak out about the endpoints unless you're like a hardcore mathematician. If you're just trying to get some basic theory, that's good enough. And 0 otherwise. Okay, so does that kind of make sense where we're trying to get it to 0 out all the way prior to t equals 2 and only come into effect right at t equals 2. So that's 1, 2, 2, 2. So basically, we're only looking at this part of the function. That's the part of the function that we want. Okay? So if we multiply it by a regular unit step, however, as we've seen, it's going to start showing up here. Okay, if we do it by a regular unit step. So really what we need to do is we need to shift our unit step over a little bit. So if we shift our unit step over by 2, okay, so if we shift our unit step over by 2, then essentially what we have is in the yellow section, we have t plus 1. But in this yellow section, the yellow section now goes from 0 all the way to positive 2. So from negative infinity to positive 2, this value is 0. So that means that in my final answer over here, my yellow section goes from negative infinity all the way to 2, and it's in fact 0. Okay? Then we have the blue section that starts, and it still is t plus 1, because that hasn't changed. And then over here, though, in the blue section, I get a value of 1. So t plus 1 times 1 is, in fact, t plus 1, which is, again, not shocking. But basically what we have is from negative infinity to 2, except I can't math very well, draw very well. From negative infinity to 2, I have 0. And from 2 to infinity, I have t plus 1. So basically what the unit step function allows us to do is it allows us to zero out things at a certain level. Now this would even work backwards. The important question though is how do you represent the unit step shifted over? And this is just kind of a standard thing. If you're at this point in differential equations or wherever it is you're doing this, you probably realize that if I want to shift something 2 to the right, I have to do t minus 2. So this is like, go back and review transformations of functions. So if you need something to Google transformations of functions and review, but basically it means if I want to move lefty-righty, I need to do the opposite of what it seems like it should be on the inside of the function. So if I want to move 2 to the right, I actually have to subtract 2, and that will get me there. Okay? Kind of getting there. All right, so that's kind of the first part of Laplace, or not Laplace, of piecewise functions. So let's pretend that that makes total sense now. So, well, let me show you. So basically we have the option, except not doing that. Basically at this point we have the option of, we could either say that this function is f of t, where t is, where it's t plus 1 for t greater than 2 or 0 otherwise, or we could say that it's u of t minus 2 times the quantity t plus 1. You'd be like, how is that any better? Because that just seems more confusing. Yes, it seems more confusing. Absolutely it seems more confusing. However, this is just absolutely 0% fun to Laplace, and this is 4% fun to Laplace. So basically we're doing all of this work so we can have 4% more fun, because yay, 4% more fun is more fun than 0% more fun, because that's what math says. Okay, let's do this. Now most of the time piecewise functions are a little bit more complicated than just 1 blah 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 or 0 otherwise. Usually they're going to be something along this. So where maybe it says t plus 1 for t going between 0 and 2, and then maybe it's, I don't know, 3t for t greater than 2, okay? Now this is where things get kind of weird. So rather than going through all of that, let's just look at this guy, actually. Let's just look at only this exact case. So we're going to say that f of t is equal to t plus 1 and 0 otherwise. Okay, so we basically have this function. So we're going to be times some things, because we're kind of getting the hang of it, has to equal this other thing. Okay, so t plus 1 is going to look like this. I have this like really weird feeling that somehow I'm recording this whole video and t plus 1 doesn't really look like that, but it has to, right? Because y-intercept and a slope of 1, okay. So basically what we're trying to say is that we only want to capture the 0 to 2 part of that function. So essentially, 1, 2, 1, 2, 3, we only want to go from here to here. So our function is going to look like that, and aside from that, it's going to be 0. Okay? So let's do this like kind of a weird little way, and you'll see. We'll try it 2 different ways and see which way it makes sense. Okay. So one way to do it is to multiply it by a function that looks like this. 1, 2, and that. Okay? So this is kind of a weird, this is not a unit step. This is actually a combination of 2 unit steps. So take a look at that and see, first of all, does that visually make sense? That basically in the 0 sections, it's 0. And so then it's 0 again. Well, yeah. So that makes this. And then in the middle, we have t plus 1. That gets multiplied by 1. And so then we get t plus 1. Okay? So start off by thinking, does that make sense? And we'll pretend you said, yes, of course that makes sense. And if that doesn't make sense, then I'm going to try to explain it a different way and then see what you think. All right, so we'll pretend that we're doing it this way. The question is, how do I describe this right here? Because this is not just t minus 2, because remember that. So I'll have to show you. I actually have to break this down into two graphs. Okay, and this is where things start to fly into your brain, and you're like, I have no idea what's going on anymore. Okay, so try this one on for size. I'm going to posit that this is the unit step minus this guy. Okay, and you're like, yeah, you lost me. I'm going to the next video. But don't stay here, because I swear it might make sense in a minute. Okay, so essentially what's going to happen is I want you to look at, so this is the unit step at regular, and this is the unit step shifted by 2. And I'm going to subtract the two of these. So essentially what's going to happen is, if you look at this, I have 0 minus 0 is 0, okay? So 0 minus 0 is 0, okay? Then in this little section, I have 1 minus 0 is 1. Okay, so I have 1 minus 0 is 1. Then in this section here, I have 1 minus 1, or 1 plus a negative 1, however you want to say it. So we'll say plus a negative. That might be easier to see. Actually, I should have done like that for the moment. So if you weren't confused before, that should do it. So the idea is that now I have 1 plus a negative 1, and everybody knows that 1 plus a negative 1 equals 0, which means that all of this is 0 again. And that's exactly the picture that we had, this kind of unit thingy that goes up and then goes down again. Okay? Maybe? Maybe. Okay. Like I said, I'm going to try it one more other way in case this just absolutely doesn't make sense, and maybe explaining it the other way will help this way make more sense. And if not, what are you going to do? It's a free video. All right. So essentially what we've got here is I've got that this is t plus 1, and it's going to get multiplied by the unit step of t minus unit step of t minus 2, because that's going to make the little top hat, and that's going to be the same thing as saying that it is t plus 1, except writing is hard, t plus 1 for t between 0 and 2, and writing is still hard, like this, and 0 otherwise. Okay? So that is one way to explain why that makes sense. Okay? Okay, let's try explaining it one other way and see if that makes it worse or better. So essentially I'm going to do now two separate things. One way I'm going to explain it, or this other way I'm going to explain it, is I'm going to have this function, and I'm going to multiply it by the regular unit step. Okay? And then what I'm going to do is I'm going to subtract off, or I'm going to add the inverse, because I kind of made that mistake last time, of that times, so I'm going to do the same thing where I have t plus 1, and then I'm going to multiply, and you're like, but that's exactly the same thing. I know it's exactly the same thing algebraically, I'm just explaining it graphically slightly different so that maybe it'll make sense, okay? It's a pedagogical strategy. Pedagogy? I don't know. Pedagogy sounds weird. I'll call it pedagogy. All right. So basically what I'm going to do is I'm going to say, okay, so this first one, you should be able to do this by now just by graphing it out or looking at it. You say, okay, yellow section, yellow section, yellow section. It's all zeros. 0, 0, 0, 0, 0. And then blue section is all times 1. So that just basically means is I have this guy at 1, and he goes up forever. Good? And again, not worrying about what happens at exactly 0 because that's for mathematicians and philosophers. All right, now here, I have this one is zeros longer. So this is all zeros. Zeros for longer. All right, and then 1, 2, 3. And then here, and this is where it's a little weird, it's -1 times this giant thing. So basically, since it's -1 times this giant thing, that means I'm going to reflect it across the x-axis. I'm going to flop it down here, and in fact, instead of being way up there, it's going to go 1, 2, 3 down here, and off like this forever. Okay? So one way that we could do is we can either think about it like the way we did before, or I could think about it that I'm taking this picture here, and I'm adding this picture here. So basically what happens is, and this is where it's kind of strange, zoom out, is if I add these two together, So let me make that a little bit more obvious. Okay, so I've got this guy here, and I'm going to add the second one, and then I want to see what that looks like. So essentially from negative infinity to 0, I've got 0, which is great. All right, then I'm adding in this little section here, that section, this section here, I'm adding 0 plus that, and so I end up with just that, right? Because 0 plus anything is whatever the other thing is. So it goes to here. And then what happens, and this is kind of the funky weird part maybe, is that from here I'm going up a whole lot, and from here I'm going down the same amount. And so essentially what happens is they zero each other out. So I don't know if that makes any more sense, or just the fact that you've seen it two different ways maybe helps the first way make more sense, but it's two ways to think about it. Okay, so what we had up here, just to kind of recap, so what we had up here was this was t plus 1, and we multiplied it by u at t, so that's u of t times t plus 1, and then this guy here was t plus 1, and then we multiplied it by negative u shifted by t minus 2. So that was u t minus 2 negative t plus 1. And so then whenever I added the two of them together, I ended up with, what was it, u of t times t plus 1, and then minus u of t minus 2, t plus 1, which of course when you pull out a t plus 1, you end up precisely with u of t minus u of t minus 2, which is exactly the same thing we got last time. It's just kind of one of those things that you gotta, I don't know, wrap your head around. If you're not a graphical learner, don't freak out if this doesn't make sense the first time. Usually you don't see this till the end of a DiffEQ class, so we don't exactly expect you to learn anything at the end of class anyway. We're just chewing up airtime till finals week. That's not true. I really want you to learn this. But anyway, you're going to see this again and again and again, especially if you're like doing a lot of math stuff or doing a lot of programming or doing signal processing. But anyway, this is just to kind of give you a basic introduction to how this is. So the whole point was we were supposed to be teaching you how to do piecewise functions with unit steps. And so if that at least makes a little bit of sense, the idea, so here's the basics. The basic idea is that I'm going to create a little top hat thingy, and that starts and ends wherever it's supposed to, and then multiply it times whatever that function is supposed to be, and not assume, but that will, in fact, give me the piecewise function that I'm looking for. So let's go back to that original, or not original, but something I made up earlier, was let's say that we had t plus 1 for t being greater than, or for t being something between something and something, 0 less than t less than 2, and then it was equal to some 3t, 4t greater than 2. So basically what we want is we want t plus 1 to be multiplied by a top hat going from 0 to 2, and then we want 3t to be multiplied by a unit step function going from 2 to infinity. Okay, so another way to write this function is to say t plus 1 times u of t minus u of t minus 2 plus 3t times the unit step shifted by 2. Oh, sorry, minus sign. Shifted by 2. And that was a really, really long explanation for a rather simple answer, and maybe it's because to me this is always kind of weird, so I really like to over-explain things that I think are weird, but anyway. So one more, let's just do one that's got a couple of top hats in it, just so you can kind of see what that's going to look like. So let's say I have a function at t, and it's defined as, I don't know, it doesn't really matter at this point, plus whatever, that, and for 3, and I don't know, 1/2 t squared plus, I don't know, 6. For this, I don't know, I'll just say, I think you get it, for t greater than 5. Okay, so we've got that. Now pause the video, see if you can come up with this. If not, I'll give you another opportunity to pause in a second, but see how far you can get on your own, all on your own. All right, so we'll pretend that happened. So your goal is you want 3 of t plus 1 times a top hat going from, that's not a top hat, that's a volcano, top hat going from 0 to 3. And then we can have 2t plus 3 times the top hat that goes from 3 to 5, and then we want 1/2 t squared plus 6 times a thingy that starts at 5 and goes to infinity. And by thingy, I mean unit step function. All right, so that means that our function at t is going to be equal to 3t plus 1 times the unit step starting at 0, and then I'm going to subtract it off at 3. So that, and then plus 2t plus 3 times the unit step starting at 3 and ending at 5. And then finally, 1/2 t squared plus 6 times the unit step starting at t plus 5. Okay, so hopefully that makes sense the top hat way. If it doesn't make sense, I can solve it the other two ways right quick, just to give you some exposure to it. So again, another way to think about it, and I'm going to zoom out a little bit just so you can kind of see. So another way, if you're not thinking about the top hat way, if you're thinking about the second way that we did it, is to say, okay, so for this guy, I don't know what I'm doing with my lines here, it's just confusing me and completely unnecessary. So another way to think about it is to say, okay, so I've got some function at t, and starting at the unit step function, he's going to be t plus 1. And then what's going to happen next is I'm going to have to subtract off t plus 1 and add in 3t, and that's going to happen starting at u of t minus 2. So that's kind of thinking about it the second way that we explained it. I just think that I like top hats better because it sounds like more fun and like you would go to a party and do piecewise functions, I guess. All right, so that's one way to think about it. And the second one down here is kind of the same idea. You'd say, okay, well, we're starting off here. Now we've got 3t plus 1, and that's times the unit step, times the unit step function. All right, and then we have to subtract it off to make room for the new guy, 2t3, and that's going to happen at t equals u of t minus 3. And then we want to subtract off the guy we just added on and add in the new guy starting at t minus 5, u of t minus 5. So if you distribute all that, you end up with the exact same answer. It's just kind of another way to think about it. So whatever way makes most sense is definitely a way you want to go when converting these piecewise functions like this.